again?
Yes. Hey, everybody. So I want to thank the previous speaker because now you're all experts in optics, or you've had a bit of an introduction. Can probably keep talking here for another few hours, right? When does the social start? Is it at... oh, it's 6, so 2 hours and 20 minutes. I better roll up my sleeves then. So, jokes aside, my name is Johan Beck. I work at Infinera, so been there 22 years. That's about as long as the company's been around. We build and sell optical transport systems. So that means, actually, we start with the indium phosphide wafers. We design the DSPs that were mentioned here earlier on, all the photonics, build a system around it, etc. Software, sell it to our customers. Let's see here. Where are my slides? Are they? Oh, but it's... do I press something or? Okay. So I will start with a question to the audience. What is it that, this is a rhetorical question. I know there are a lot of engineers in the room. What came out in 1984 and has 7 layers? Okay. So being in Denmark, my favorite Danish invention is this pålægschokolade, but that's only 1 layer, and I think it's been around since 1963. Okay, so it's not that. My slides still aren't here. It's not Dante's Inferno, because that's like 700 years old, and I think it's 9 layers of hell, which is what networking can sometimes feel like. What else is it not? Let's see here. Any more guesses? Could it be 7-layer dip? Anybody been to Texas? It has 7 layers. This is from 1984. No, it's actually, anybody know? It's 1982. So if anybody had guessed that, it would not have been a bad guess at all. Oh, toilet paper. That's 7-layer toilet paper. That's Rolls-Royce toilet paper. I don't know where to buy it, but thank you. Very good. All right. So it wasn't the 7-layer dip. It's the OSI model. All right. So it has 7 layers, and it actually was first published in 1984. And I think maybe some people would argue that there's a layer 0 somewhere down in the basement. I don't know when that was added, but at Infinera, we work at layer 1. I think a lot of people here in the room work at layer 3. And I wanted to say ignorance is bliss. This is what the OSI model is built on. If you work in a layer, you basically hide all the complexities from people above you, right? And you also don't have to worry about the stuff that's downstairs from you. So, for example, ignorance about layer 1 is bliss, I would argue, right? And that's, at layer 1, we try to, keep people above us from not having to worry about things like OSNR, nonlinear penalties, all these things. Ignorance about layer 3 is also bliss. For the past 4 years, I've been touring around in EMEA here because we're developing coherent pluggables, right? So I've had to learn quite a lot about the layers above. It's really interesting, and there's a lot of amazing things going on, as we have heard here today, right? So when I put the title of the talk together, I wanted to talk a little bit more about IP optical convergence, which is a topic that's been around for a long time. I did a search on Google yesterday, and I think I found like all the vendors had said something about it. Very few network operators, at least not on the first page. So Ericsson, there's a link that's 10 years old, right? Something from Sienna. Roger, you're here in the room somewhere, right? Cisco, Juniper. Everyone's talking about IP optical convergence. And why is this? Should we take these layers at the bottom and just collapse them into one big... I don't know. It's great to see everyone here in the room, but I don't know if I could learn everything. So what's happening is that there's this rise of coherent pluggable optics, as we heard from the last speaker. Optical technology has shrunk so much over the last 2 decades. When I started at Infinera in 2001, we were working on something called photonic integrated circuits. which allowed us to build like tiny photonic components, right? 100 gig optical chips that we first started selling in 2004. They were sitting in a chassis the size of a fridge, 400 gig of capacity, some switching, some cool software features. And now today, a QSFP-DD, it has basically the same functionality. And now I feel old, right? For the first time in my career. But what happens when you take something that's the size of a fridge and you make it the size of a finger? Well, it means you can start using it in a lot of places. So the hardware architectures of networks will be very, very impacted by this, and this is something that's happening now. You can take this piece of layer 1 equipment, DWDM equipment, and you can put it in a layer 3 device. You can put it in a server. So we heard something about smart NICs and DPUs earlier. You can get a DPU with a QSFP-DD cage, and why not put a coherent interface inside that? Mobile transport, radio units, baseband units, 5G advanced 6G networks will need a lot more bandwidth than mobile transport has seen in the past. So this is being discussed everywhere, and this is why people are talking about IP optical convergence. Something about performance. So when you want to start using these small transceivers, right, in large transport networks, the performance has to be good. And it's getting to that point now. We did some tests in Aurelian's network a year ago with our 400 gig 16 QAM plug, and we announced error-free transmission over 1,800 kilometers, which is still the best announced to date, result to date that I'm aware of. Maybe anybody from Aurelian in the audience? Thank you. And if that's not good enough, the next generation 800 gig pluggables, which we're already working on, we'll have some hardware at OFC later this month. They will basically go to the moon and back if you run them in the 400 gig mode. So the hyperscalers, they want 800 gig now, but most service providers will be happily running these as 400 gig QSFP-DDs, and you can go, 4,000 kilometers. This is under ideal conditions, so you run this over a nationwide network. You're going to need really, really good fiber and amplifiers to achieve this. So let's see. So IP optical convergence, it can happen from a hardware architecture perspective, but there's more to it than that, right? So I don't know which AI came up with this. There was no AI involved, it was just me. But so this OSI model is actually reflected in many network operator organizations as well. You have people who are used to seeing CLI, dressed in blue here. Maybe they work with layer 3 equipment. And then you have their transport colleagues. They manage networks in using very different tools with GUIs, there are amplifiers and things involved. And it's very hard to get these to talk to each other. They may sit in different cities, different offices. If they sit in the same office, they may not have lunch together. And the people operating the routers probably don't trust the transport folks inside their routers in their CLI. So this is where a lot of work needs to happen to basically allow this new hardware architecture to be operated in a real network. So when we talk about how can we use these coherent plugs, right? I think client optics, the way we're used to connecting to router ports, you look at how much loss is there. Is it 5 dB or is it 7 dB? Should I have a short reach, intermediate reach, a long reach or extended reach client optic to connect them? And this is where the 400G ZR plugs came out, driven by hyperscaler use cases, where you're basically going across town over a certain amount of attenuation. But transport people, they have amplifiers. There are things called ROADMs. There are a lot of bespoke equipment that make up a line system. And you have to worry about this thing called OSNR that was described earlier, nonlinear penalties, and a lot of analog effects So what DWDM vendors like Infinera, what we have is we have an army of system engineers armed with network modeling tools that can sit down and tell our customers, like, this will work over life, and we guarantee that it works in your line system. We'll sell you the line system. We'll now sell you the plugs, because this is the way the world is going, right? But the languages are very different, and the use case on the left with dB loss is very, I'd say, developed, and the use case on the right, where you're using pluggables over line system, this will take some time. So people are proposing different software architectures that allows, let's say, an optical controller, or it could be a transport network management system, to talk to the plugs sitting in a router. So if you follow the green arrow there from the optical controller, it may have to go over to a packet controller that then talks to the router, and the router talks to the plug, and this becomes a bit of a Chinese whispering game. And you also have to wait for everyone writing the code for those boxes, right? The router OS, the packet controller, to implement new features. And features are being added very rapidly now in Coherent Pluggable. So I don't know, from an automation perspective, how many of these boxes do you want to go through, right? Looking at Alan, and from your talk in the morning here, maybe you want to bypass the packet controller if you can, right? So the packet controller doesn't have to understand, I don't know, modulation formats or frequencies or the information models that come with the new plugs. So there's a ton of discussion in the industry about how to do this. I'm not going to go into those details. But are there other ways we can do this? So if you look around, like the total ICT industry, it's not, it's a lot bigger than the networking. Cell phones, does anybody know that you can go into your cell phone and see which, there's like a hash star number of digits command you can type in, and it will tell you which cell tower you're connected to? Anybody care? I would expect a few people in here to care, but most people absolutely don't care. They want connectivity, right? They don't, but somebody at like Telia, they know which cell tower my phone is connected to and which time slot and frequency I'm connected into. So how can we make pluggables easy to use, so like cell phone? Provide fibered connectivity the way that we're used to getting wireless connectivity. There's also a thing something called Internet of Things. You think about it, it's small things, maybe battery powered, deployed in millions. There's a whole set of software already out there. You look at pluggable optics, they don't have a whole lot of power. They don't have, there's no screen, there's no keyboard. Why don't we try to solve the same problems using already existing tools, right? So that's what we've done at Infinera. We put a lot of thought into our plugs. I just stole a marketing slide. But we have a little, you can use this like any old plug, Coherent Pluggable, using the standardized CMIS register-based info model, or it becomes a managed entity. So we have a little Linux stack running on the plug, IoT, very, very small. You can't do much on it, but at least you can plug it into your router and assign an IP address to it, and off you go, right? So what this allows us to do, something we can demonstrate today and have been doing to a lot of customers, is to basically let the optical controller talk directly to the plug inside the router. So don't worry, you can still use CLI to do the basics, that you're used to, but you can tell your colleagues from the transport department that when you install that plug, it's going to show up, auto-commission itself into the transport network management system, and they can be rest assured that they can manage that wavelength as if it were a standalone transponder. So this is something, there are different ways of doing it, and hopefully we can all be in a room and talk to each other if we work smartly together. So with that, I wanted to say that the social is here pretty shortly, right? And we'll be happy. We're here with our reseller, Itectra, They're based here in Denmark, and we'll be happy to take questions later tonight. Look forward to seeing you all. Thank you. Any questions?
Anybody? People are tired and ready for the social again.
All right, great. Thank you all. It's a pleasure. Thank you.